Why is the ocean so deep? Why isn't it just flat, like a giant swimming pool covering our planet? The answer takes us on a journey billions of years into Earth's history and deep beneath its surface. First, let's start with some basics. The average depth of the ocean is about 12,100 feet. That's more than 2 miles below the surface. The deepest known point, the Mariana Trench, plunges nearly 36,000 feet. If you drop Mount Everest inside, it would still be covered by more than a mile of water. But why do such massive trenches exist? Why isn't the ocean floor simply flat? The secret lies in plate tectonics. Earth's outer shell, the lithosphere, is broken into gigantic plates that float on the hot, slowly moving mantle beneath. Where these plates interact, incredible geological features are created, subduction zones. When two plates collide, the heavier oceanic plate dives beneath the lighter continental or oceanic plate. This process carves out enormous trenches, some deeper than anything else on Earth. Mid-ocean ridges. In contrast, when plates move apart, molten rock rises and creates vast underwater mountain chains. The Mid-Atlantic Ridge, for example, stretches for more than 10,000 miles, longer than any mountain range on land. Nowhere is this more dramatic than the Pacific Ocean. Surrounded by the famous Ring of Fire, it's a hotspot of subduction zones and volcanic activity. That's why the Pacific contains the world's deepest trenches, like the Mariana, Tonga, and Philippine trenches. These are scars of violent collisions between plates, constantly reshaping the ocean floor. But the ocean isn't just trenches. It's a world of underwater mountains, valleys, and ridges. There are thousands of seamounts, underwater volcanoes, some taller than Mount Everest, though hidden beneath the waves. This dynamic seafloor creates diverse habitats, from dark abyssal plains to hydrothermal vents that spew superheated water. Life thrives in these extreme places. Organisms that don't even need sunlight, surviving instead on chemical energy from the Earth itself. If Earth had no plate tectonics, the oceans would look very different. Without trenches, ridges, and constant recycling of the seafloor, our planet might have ended up with shallow seas, or maybe no stable oceans at all. In fact, many scientists believe tectonic activity is one of the reasons life has flourished on Earth. It regulates carbon, recycles nutrients, and creates the environments where life can evolve. And here's the most mind-blowing fact. We've mapped the surface of Mars better than we've mapped the bottom of our own oceans. Over 80% of the seafloor remains unexplored. Hidden valleys, mountains, even undiscovered species. They're all waiting in the darkness below. The ocean floor is constantly changing, shaped by forces deep inside the Earth. Will we ever fully explore its mysteries? Or will it remain one of the last frontiers on our planet? If you're fascinated by the secrets of the deep, make sure to subscribe and join us as we dive even further into the unknown.